Hi Algebra 2. I wanted to go over 3.1 here with a video. I'm gone today, as you can tell, and thought this might be the easiest way to present the information to you. A couple notes on the test retake. Mrs. Z has the review if you just want to get that from her. I'll let you go ahead, take it home if you want. If you have any questions, bring it back, but that needs to be done in order to do the retake on tomorrow or Wednesday or rest of the week. I'm gone also Thursday, Friday, so if you want to take the test Thursday or Friday, we need to set up something. But if you want to go ahead, get started on the review, you can just ask Mrs. Zimmerman. I'll leave the copy with her. And we'll go ahead, start with section 3.1. Little joke, I guess, on the bottom. What did the green grape say to the purple grape? You'll have to wait until the end of the lesson to see. So we'll go ahead and start here. I'll have you go ahead and do the bell ringers here. Please add this to your previous bell ringers. I don't think I picked them up last week, and if I did, go ahead, just start a new sheet for me, please. Go ahead, hit pause, and when you're done, go ahead, unpause it to see the answers. So here you can see the answers. The first one, just make sure it's 2 to the 4th. That gives you 16, and then you have the negative out in front, so that's negative 16. The difference with 2 is you're taking negative 2 times negative 2 times negative 2 times negative 2, which is 16. 1, you're really going negative times 2 times 2 times 2 times 2. So make sure you enter those in correctly on your calculator. I know people sometimes will mess that up. They want to do negative 2 to the 4th, but in order to do that on your calculator, you need parentheses. 3, distribute negative 2, so it becomes x minus 6x plus 2, and then add like terms. And 4, just distribute, so you get 3y squared plus 6y. Section 3.1 deals with polynomials. So far we've seen chapter 1 was everything to the first power. Chapter 2 was everything to the second power. Now with polynomials, we'll see things that are different. Just different powers that won't be necessarily 1 or 2. You might see third power, fourth power, fifth power, and so on. Running through the vocab in this section, monomial, think like monorail, is just one term. Polynomial is more than one, so usually 2 or more. Degree we'll talk about. Leading coefficient you'll see here in a second. Binomial, that's 2 terms, think bicycles, 2 wheels. Trinomial, that's 3 terms, think tricycles with 3 wheels. And then we'll also talk about polynomial function. I'll let you read through monomial and polynomial. Again, though, monomial is 1, polynomial is more than 1. The examples here are pretty good. What makes polynomial kind of a polynomial is the powers here have to be whole numbers. It can't be negative. So here you see 4, 12, 3, 7, 101, 2, 3. Those are all good examples. Non-examples can't have a variable as a power. Can't have absolute value, can't have a squared on the bottom or the denominator. 1/2, you need something more here, x to some power. Can't have a decimal power. So these are some non-examples that are pretty good. Degree of a monomial is the sum of the exponents of the variables. And this is a question people miss come test time. Might be something you want to note. That way you remember it in 2 weeks when you take the test. But I try to give you hints throughout the chapter that this is going to be on the test. Students missed it in the past. You might want to take a note of this so you don't mess it up down the road. To figure out the degree of a polynomial, you just need to add all the exponents. So first one, z to the 6th, should be pretty easy. It's just a 6th degree polynomial, or I should say monomial. B is 0 degree, because I can write 5.6 x to the 0 power, and you'll see that on the next slide. C, 8x y cubed, it's x to the first y cubed, so add 1 plus 3, that's a 4th degree. And D is going to be similar, it's 2, b to the first c cubed, so it's 2 plus 1 plus 3, which makes it a 6th degree, and you'll see the answers here in a second. Here's the answers all written out. So A should be pretty easy. B might be a little bit tricky because it's to the 0 power. Remember, anything to the 0 power is 1, so it's really just 5.6. C, you can see the red 1 plus the red 3 gives you a degree 4. And similar to D, you got 2, 1, 3, add those up, and it is a 6-degree monomial. Well, if you go ahead, try these, should be pretty similar. Hit pause and see if you can get the right answers here. If you haven't hit pause, go ahead, hit pause now, and I'll give you a chance to look at the answers. So hopefully you got all these right. First one's degree 3, second one's 0, C's 5, and D is 9. Next thing to look at is polynomials. Here it's just going to be usually the highest degree is going to determine what degree it is. So here you see x cubed is the highest down here in the example. And this would be a 3rd degree polynomial, or it's going to be called what's called a cubic. Second we saw was quadratic, or and 1st degree would be linear. A couple other things here. You have your leading coefficient. This is the number that always goes with the highest power. So here our leading coefficient is 5. It's a 3rd degree polynomial. And how many terms are there? Terms are separated by plus or minus. So there's 1 term, 2 terms, 3 terms, 4 terms in this example. A couple different binomials or polynomials. If you have 2 terms, it's a binomial. 3 terms is a trinomial. Anything usually greater than that, they'll just say 4 terms, 5 terms. Here's a table of the degrees. You can see the name and an example with it. You can hit pause and read it through here. Usually we see everything constant, maybe up to cubic. Quartic, quintic we see sometimes, not often. And then anything above that we'll just say 6th degree, 7th degree. There's not an official name for them. So in this example, you got to do a few things. You got to identify the leading coefficient, the degree, and the number of terms, and you're also going to name the polynomial. So part A, the first thing is what degree is it? That's the highest power. So if you look here, it's not written in standard form. Standard form goes highest power all the way down to the constant, but my highest degree is here. This is 2nd degree, or what we'd call a quadratic. Leading coefficient, it's not 5, it's going to be -5 here. Number of terms, I got 1, 2, 3. So the official name you can probably say is a trinomial, and it's a quadratic with a leading coefficient of -5. B is going to work similar, it's a trinomial. Now it is a 4th degree, so this would be a quartic, and the leading coefficient is 8. Here's the book's answers, so you can go ahead, hit pause, and read through it, but it should be pretty similar to what I just said. With polynomials, you can add or subtract. Here, when you add or subtract, they have to be like terms, so it has to be to the same power, same variable. The books here gives you an example of adding horizontally or vertically. I don't have a preference. If it says one way, you can do the other. That's fine. I like subtraction horizontally or adding horizontally. To me, it just seems like it saves paper space. You don't have to write vertically, but I'll give you examples of both here in a second. Here I just wrote out all the work, or the book did, so you can see how to add vertically. There's no x squared in the one term, so they just leave it blank. You could have put plus 0x squared here if you need the space holder. But here, just add all the colors vertically. I said I usually don't add vertically just because it seems like it takes 3 lines of work where you can write it in one with going horizontally. So here you can just see 2x cubed plus x cubed, 5x squared plus 0x squared, -x plus 7x, and 9 plus 4. And that gives you the sum down there. Next example will show you horizontal. So here's an example with subtraction horizontally, and here be careful, just like what we saw last chapter, distribute the negative first and then combine like terms. Otherwise people tend to not distribute the negative and get it wrong. So this should be -x squared minus 6 plus x. And now when you add like terms or combine like terms, you should get -3x squared plus x minus 3. I'll have you go ahead and try this one. So go ahead, hit pause now, and when you're done, hit on pause and I'll show you the answer. So main thing with subtraction, distribute the negative. So it's minus 15x squared minus 3x and plus 2. And that's what you see here. Once you have that, now it's just adding like terms. So 5x cubed, there's no other. X squareds are your yellows, or sorry, oranges, so they're being added here. Next thing we need is x's. There's none over here. And then the constants, which are the greens. And add them all up and you get this. This is written in what's called standard form. It takes the highest power, which is cubed. Next one, 2. Next one, it's not written, but it's 1. And 14. And it's really x to the 0 power, but we don't write it. So your powers descend 3, 2, 1, 0. And this is kind of the norm way of writing things. So when you write polynomials, do write them in this format with the highest power and then descending down all the way to the constant. Next problem, really nothing new. It's just a story problem. They give you a function and you need to evaluate f of 0 and f of 200. Anytime you're doing that, just like we've seen in the past, just plug in 0 for all the x's and solve. You get 45. Or plug in 200 for all the x's, solve, and you get this large number here. Just like the other chapters, you're going to have to graph. So do use Desmos on these, and we'll look at a couple examples here. So when you have the graphs, it's going to say graph, and then do a couple things. Describe the graph and also identify the number of real zeros. So if you look at the first one, it's increasing all the way up to here, decreasing, then increasing. The number of zeros is how many times does it cross the x-axis. I got one here, and one here. So this one's going to have 3 real zeros. Next one, increasing, decreasing, increasing, decreasing, and how many zeros? You got one here, one here, one here, and one here. So this one has 4 real zeros. Another set of examples, increasing, decreasing, increasing, and this one has 3 zeros, 1, 2, and 3. This one, decreasing, increasing, there are no zeros for this one, so it says no real zeros. Next slide, I'll let you try 2 of them here. So go ahead, hit pause, tell me how, describe the graph, so that's increasing or decreasing, and then tell me how many numbers of real zeros. Hit pause and I'll show you the answers here when you're done. So here you can see the answers. It's decreasing and then increasing. How many zeros are there? Looks like there's 2 real zeros for this one. Next one, decreasing, increasing, decreasing, increasing, and 4 zeros. One here, 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 and here. So you get 4 real zeros. This ends this section. Hopefully everything makes sense. If not, you can go ahead, go back and look at the book. You can watch the videos at my.hrw.com, or you can go back, rewatch this video, and hopefully things will click for you. If not, I'll be back on Tuesday and you can ask questions on it. Homework for the rest of class time is page 155, and it's 20 through 48 even. And to answer my joke at the start of the question, or start of the section, what did the green grape say to the purple grape? And he said, quit holding your breath and breathe. Hopefully you get it. If not, I'll explain it on Tuesday, but have a good rest of the day.